Okay, let's go ahead and get started on Chapter 8. This is the user interface design. This may be a long, as I was looking through the notes on this, this may be a long chapter. I'll try to hurry it up a little bit. Actually, a fairly simple chapter activity, but a lot to talk about with using this. You can see the objectives up here. And our goal this time is to take what you have learned and to interface it with something like data entry. So fairly simple chapter, but a lot to talk about when it gets down to it and what we have to do. So our goal of system design is to, and you can read that, effective, reliable, and maintainable. I like the maintainable, especially the scalable. Now, what does scalable mean? Well, it means as my business, company, project grows, then this should ratchet up with it. The last thing you want to do, as I mentioned in a previous chapter, the last thing you want to do is to create something that gets outdated in a few years, because then you go through that expense and the headache of going through this entire project all over again. So you don't want to do that. Think like a user. I've said for years that some of these projects or programs that we deal with were created by scientists and not users. Users need to be in the middle of this. I've used products from book publishers before, and sometimes it appears that the software developers developed everything without the knowledge of the faculty. So think like a user. Make sure you know, and how do you do that? And we'll discuss that at a later towards the end. But think what they would do, and try to make sure it's something that can be entered. The data can be entered, and it can be done without a whole lot of difficulty or mistakes. It's got to be. I've got a slang word that I use, and this is probably not a very courteous word, but I call it idiot proofing, and it just means make it. A gentle way of saying that is to make it so that somebody could not enter something. For instance, if they were supposed to put a social security number in and they start typing letters, or if they try to type 4 numbers, instead of 3 initially, then it would stop that and allow this to do this. What is a user interface? A user interface you can read right here. Human-computer interaction. You all do that right now. The computers today are very intuitive, which means they operate the way you think and the way that you do it. Look at smartphones. Look when smartphones first came out. If anybody remembers that, they've been out about 10 years now, and when they first come out, they were very difficult to use, and it almost took a user manual. Now they've got to the point to where they all, you can pick up somebody else's smartphone and begin using it automatically, or if you upgrade your smartphone, you can use this. It needs to be something easy to learn, though. When it's tough to learn, the learning curve is straight up, then it becomes very difficult, and I wouldn't recommend creating something like that. So here's the seven habits of successful interface designs. Is you must know what the business is all about. How do you do that? Well, you understand your business, and so you do a lot of research. Now, if you have a large company, you may only understand your section or your department or your area. You need to understand the whole company and how you interface with the rest of the company. It's important that this happens. What does that mean? It means you ask questions and you get outside of your department before you design anything. The graphics ought to be simple enough to not tie a screen up or multiple screens. Again, I've already told you, think like a user. Model and prototype. We discussed modeling and prototype back in chapters 1 and 2. And you want to have a prototype that can be, before you put it online, you want to make sure it works. So you develop a model, a prototype, you test it. If it works, then you come back and you make improvements, you make suggestions, and you move on there. It must be usable. It needs to be something that people will want to use as opposed to having to use. Must be something, look at student services over to the right. Believe it or not, that bottom right hand gets left out sometimes, exit system. I've seen interfaces that were caught up and they put the user in a loop where you can never get out of it. You get out of it by closing the program down. That's not a good system. So make sure you can get out of it. How do you do that? You test it and test it and test it. You have somebody come in. Sometimes when I create an exam, I'll have a student worker that has already completed my class. I'll have a student worker take it. He or she are happy to take it, and have them take it and see what they think. Gee, that's too hard, or piece of cake, or yeah, it's a pretty good exam. They've already completed my class, so there's no reason to tell me anything other than the truth. So test this out. Invite feedback. Be careful. You may not like what you hear. Have thick skin. Write down everything. Everything that happens, document it. Okay. Mentioned all of this, most of it already. Again, familiarity. Keep it familiar with something that people would understand. Now, let me go back there and mention something else. Be careful know the population that you're dealing with. If you work for an international company and you're creating something for all people, make sure that you don't have something that maybe somebody from India or Pakistan or Kaiserslautern, Germany. Make sure that you do something they would understand. Be careful. So make sure that your images are international. Images make sense. Also make sure they're not condescending towards a particular ethnicity or a race or something else. Just be careful how you do that. Make sure that users have help and feedback. Never create a screen without a help. And also make sure that is F1. Your key F1. That's a universal help screen key. So always put a help screen in here. That help, if you don't have a good help system, it may just be, if they click on F1, it's got your phone number or your email address down there. That's pretty easy to program in. But make sure they have this and what you want to use. Provide users with this. Make sure you have an undo key if possible. Now with databases, that's pretty hard to do. As you'll notice if you ever work with Microsoft Access or any other database program, sometimes once you click it, it's done. So I always tell students on databases, all bets are off with undo. Sometimes you can undo it, most of the times you cannot. If it has any kind of function built in, that's because there's too many translation problems inside or steps inside of Access in order for this to happen. Just an example of a user interface design. Make it attractive, make sure it looks nice. Again, ask people questions when they use it. What would you like to see different? Again, programmers sometimes don't think like other people. So sometimes they will do exactly what you ask them to do. So if you want something to interact and work the way you want it, it's okay to go back to them and say, this is great, could you make it like this? Could you do this? I like the last bullet on here. When dates are entered, use a calendar control, which means when they click on something, it drops a calendar down. There's nothing worse than, should it be day, month, year, month, day? Can you abbreviate? Is it alphanumeric? Do you put DEC in for December, or do you put 12 in for December? Again, If you have a calendar where they click on that, it drops a calendar down. Then you have toggling for the month and for the year. Then they have the day out there on the calendar. Then you have it out there. A piece of cake to do it like that. Best way to do it is you can do this right now. Always have data entry screens. You're going to create a data entry screen too towards the end of this. I'll explain that, but make sure that when you have something, little things that you use now you take for granted. For instance, if you start typing in a last name, if you type in H, then it should list all the students that begin with H. If you type in HA, it should list all the students that begin with HA, and so on and so forth. That way it will save having you having to type in the entire name or typing in a number or something else. So keep this as user-friendly as possible. Form filling method, I just finished talking about that. Input mask, if this were a database class, we would discuss this in detail. What I'd like you to know right now, though, is this mask for entering data, the day would be month, day, year, which means your month would be 01, 02, 03 or 10, 11, 12. The day would be 1 through 31. And again, you can set criteria. So if they put 32 in there or any other number other than 01 through 31, then you'd get an error message. And the year, you have to be careful on the year because you can program this out where they could put in something really silly. I would probably put a criteria statement in here, and depending on what the date is for, if it's the current date, I'd probably put a 10-year from now until 10 years from now. If it's more than 10 years, it would get an error message, and if it's less than today, it would get an error message. So just my thoughts on programming. There's your input mask. Validation rules. Again, if you put the rules you want in there to validate that, it can be as simple as numbers instead of letters, or it can be as complex as something involved with a sequence or the entire mandatory data items. For instance, if you're asked for a trying to find a student and you left out the birth date for the student, then it would go back and tell you must have that date in before it can proceed. I like the reasonableness check. Again, it looks at patterns, and if a pattern appears to not work, good example, you have a student that's 12 years old as a sophomore in high school and a sophomore in college. It's probably not normal. Can it happen? Absolutely, it has happened. Is it normal? No, it would question you. If you agree, then it allows you to go, but it would question you. You can see the rest of them. So the guidelines for this, you're trying to reduce the input volume. Constant data doesn't need to be put over and over and over again. If you're working on students to enter into the system today, and this is the year 2017, then 2017 is defaulted. No sense in having people type 2017 every time. So you can have that defaulted, and then if it wants to change to something else, if somebody wants to change it, I don't know why they would for today's date, but if they wanted to change that, you can change that right there. GIGO, I've used that for years. Garbage in, garbage out. Students hate to hear that, but that's usually the way it happens. You put junk in, you get junk out, and you just leave it at that. Form design. I'm not very good at design. I'm better at maintenance, but I've had to design forms and had to design documents before. Again, I don't do a great job on design work. I'm just not built that way. But this course will ask you to be better on what you're doing. The printed output, make sure you know what's being printed and where it's going. I've seen companies that their printing is set up to go to a different printer. They print out something that's not for all eyes to see, and it goes out to a universal printer someplace, and everybody sees it, and that's not good security measures. So make sure you know, will it be going to a specific device, and that should be as part of your form. Where's the output? Is it going to the screen? Is it going to a printer? Is it going to a, whatever it's going to? Printed output for reports. I like exception reports. Case in point, at a previous job, I had reports that were delivered to me. It would be too much for me to actually read. I got them every week. It would be about 2,500 pages for me to read a week. That's not good. So I stopped that report and asked for an exception report. That 2,500 pages was reduced to about 4 pages. All I want to know are the problem areas. If everything else is running well, leave it alone. Now, that can be also turned into a summary report, which I later had sent to me. So make sure you know what you're getting. I wouldn't do detailed reports for everything. Regardless of what your job is, I wouldn't do it for everything. Now, you may want those quarterly or annually or something, so you can get baseline and you can really spend some time getting into it and looking up stuff. But normally, exception reports are good. I'll let you look through all this. Your book does a good job on the design for this right now. If this were a database class, I would ask you to be doing reports, and this is an example of a report. Notice it's pretty easy to see and look and see it's easy to look and evaluate what you're trying to find out. You've got employee hours, you know the store, you know the name, the position, how many hours each person worked, if there's any overtime, and then the total hours. Obviously, you could use total hours for budgeting purposes. You could use overtime hours to make sure no one is being overworked. You can use the position to see how long or what that person is doing and who is working overtime. So a lot of questions can be answered right here. Output technology I've talked about already. Again, know where it's going before you send it. Output technology more, specialized. Input technology, how is information coming in? Again, we began this class talking about input, process, output. So the keyboard, OCR, microphones are different ways of getting stuff in. You have you can batch input that can input stuff automatically, and then you can work from there. What do I want to say here? Sometimes the input can be magnetic ID cards. As I told you all back in early chapters, I think chapter 1 talked about time clock as an input device. I don't know of anyone that uses a time clock anymore. There are companies that probably do use a time clock. That's expensive. Of course, it's costing nothing as long as it doesn't break down. It costs nothing because they already have it there. That is called a sunk cost. It's already there and been paid for, I'm sure. People have to go to the trouble, though, of remembering to do that. Now, if it breaks, I would not repair it or replace it. Can you buy time clocks? Probably. Should you? No. It's too easy now to produce cards where even RFID chip cards, as soon as the employee walks in, it logs them in. When they leave that day, it logs them out. I mean, to me, that's just a no-brainer. But again, companies have to purchase that, although it's not expensive. Trade-offs: slower, more expensive than batch input. Output and control and security. And I'm going to wind this up pretty soon. We're going to finish this talking about you need to know what is going out and where it's going out to, as I've mentioned many, many times. Input, correct data is important. that you get stuff in. Again, we're using GIGO. Modular design. Again, we take and set stuff up. The object-oriented programming, using objects or modules to design everything, and I would always design a process using that, and then make sure you show the flow. Prototyping is the looking to see what is going on and where it's going on to. So where do we go from here? The benefits of this prototyping, I mentioned that. System requirements. Now the chapter activity, I would like you to design a data entry screen. There's examples in the book. I don't care what you use to design it with, as long as it's Visio. That's a hidden joke. Please use Visio and learn how to use Visio using the data entry screen. I'd like you to draw a screen. You can see examples. Don't copy the book. You design your own screen and show boxes and blocks on here to work with. And then I'd like you to do the online tool rental screen for the activity that's listed there. And again, design that using Visio. And then you'll learn how to use Visio just a little bit. You're putting blocks inside of that. You can put names in there, whatever you want to do. So use that, make it look nice and presentable, and that's all I want for this week on the chapter activity. And from that, we'll look at the summary. Systems design, we want to create a physical model of the system that satisfy the requirements that we listed. We talked about reports, detail, exception, and summary, and then looking at the different types of these, and then different parts of a document, and then input methods for data capture and data entry, then a little bit of security. So that's all I have. Good day.